Hello everyone, my name is David. Today I'll record this video. Let's get started. Black holes are one of the strangest things in existence. They don't seem to make any sense at all. Where did they come from? And what happens if you fall into one? Stars are incredibly massive collections of mostly hydrogen atoms and collapse from enormous gas clouds under their own gravity. In the core, nuclear fusion fuses hydrogen atoms into helium, releasing a tremendous amount of energy. This energy, in the form of radiation, pushes against gravity, maintaining a delicate balance between as long as the fusion core star remains stable enough. But for stars with way more mass than our old sun, heat and pressure at the core allow them to fuse heavier elements until they reach iron. While they all element way before, the fusion creates this doesn't generate energy. Iron builds up at the center of the star until it reaches a critical amount, and the balance between radiation and gravity is suddenly broken. The core collapses. With a fraction of a second, the star implodes, moving at a quarter of the speed of light, feeding even more mass into the core. At this very important, all the heavier elements in the universe are created as the star dies in a supernova explosion. This produces either a neutron star, or if the star is massive enough, either a massive core collapses into a black hole. It looks like a black hole. What you would see is the event horizon. Anything that crosses the event horizon needs to be traveling faster than the speed of light to escape, or in other words, it's impossible. So we just see a black sphere reflecting nothing. But if the event horizon is the back part, what is the whole part of the black hole? The singularity. We're not sure what is it exactly. Singularity may be infinitely dense, meaning all mass concentrated in a single point in space and no surface or volume. But it's something completely different. Right now, we just don't know. It's like a dividing by zero error. By the way, black holes do not suck things up like a vacuum cleaner. Here to swap the sun for an equally massive black hole, nothing was changed from Mars to Earth, except we would freeze to death, of course. But what happens if you fell into a black hole? The experience of time is different around black holes, and from the outside you seem to slow down and approach the event horizon. At some point you will appear to freeze in time, but slowly turn red and disappear. But from your perspective, and watch the rest of the universe and fast forward, kind of like see into the future. Right now, we don't know what happens next, but we think there's one of two things. One, you die a quick death. A black hole curves space so much that once you cross the event horizon, there's not only one possible reflection. You can take this literally from outside the event horizon. You can go only one direction. It's like literally being tight alley, the closest behind you every step. The mass of a black hole is so concentrated, at some point a tiny distance from a few centimeters would mean gravity acts with a million times more force in different parts of your body. The cells get torn apart, body stretches more and more until you're a hot stream of plasma, one atom wide. Two, you die a very quick death. Very soon after you cross the event horizon, you'll hit a firewall and determine in an instant. Neither of these options are particularly pleasant. How it die depends on the mass of a black hole. A smaller black hole would kill you before you enter its event horizon, while you could travel inside a super-sized black hole for quite a while. In a rule of thumb, the further you go from the singularity you are, the longer you live. Black holes come in different sizes. There's stellar mass black hole, a few mass out of the sun, and the diameter of an asteroid. Then there's supermassive black holes. Well, I have found that every part of galaxies have been feeding for billions of years. Currently, the largest super black hole known is S5001 plus 81, 40 billion times the mass of our sun. It is 236.7 billion kilometers from Earth, which is 47 times the distance from the Sun to Pluto. As powerful as black holes are, they'll eventually evaporate through a process called Hawking radiation. To understand how this works, we have to look at empty space. Empty space are not really empty, but filled with virtual particles popping into existence and aligning with each other again. This happens at the right end of a black hole. One of the virtual particles will come in and the other will escape and become a real particle. So the black hole is losing energy. This happens incredibly slow at first, and it gets faster as the black hole becomes smaller. And it arrives at a large asteroid. Its radiation is at a room temperature. And when it has a massive mountain, it radiates about the heat of the sun. And it's then the black hole radiates away with energy of billions of nuclear bombs in a huge explosion. But this process is incredibly slow. The biggest black hole we know might take a go-go of years to evaporate, so long that the last black hole radiates away. Nobody will be around to witness it. The universe will become uninhabitable long before then. This is not the end of the story. There are lots of more interesting ideas about black holes. We'll explore it in part 2. So that's the end of the video. Thank you for listening. Goodbye.